This is 4.8, day 2. We focused so far on right triangles and angles of elevation and depression. Today we're going to focus on the circular trig and some real world problems. So I've already shown you this slide before. We're going to look at an example that works with maximum minimum monthly temperatures. There's also an example in your book that you can look at in a different textbook talking about tidal variations. So what we're going to do is have you write down this data right here. So this is a 12-month snapshot of the monthly temperatures for the Cape Town, Africa. And each month they put the mean temperature. And then they constructed a graph. In our notes today, we're not going to have you take the time to graph it out, but in your homework, you will have to graph it out. So what I do want you to do for your lesson today in your notes is to write down these set of data. And you may want to write above the months, January being the first month, February, March, April, and just continue on. And then what we're going to do is we are going to find out what is the equation for the sine function of this set of data. So we're going to find the amplitude. We're going to find the period. We're going to find the horizontal shift change. We're going to find the vertical shift change and create the equation for this set of data. Then to kind of explain how they graphed this, if this is January, month 1, on your horizontal axes, you're up at 28 as your average temperature. Then this would be February, month 2, you're at 27. At March, you're at 25.5. And they just continue this graph. And this creates a sine wave. Do I have enough time to write those down? We'll refer back to this graph in a little bit. Okay. This is the same data. So, here is our objective, is to write a model for this data using y equals a sine of b of t plus c plus d. Remember, a is found with your amplitude, the b is found with the period, the c is at horizontal shift change, and d is your vertical shift change. So you can do them in any order. I'm just going to start with finding the period. So you have to figure out how long a revolution is. In this case, it's 12 months, where the cycle then starts to repeat again. And you can see it from the graph. if I start here in January, and then I pick back up again, that is one cycle, one revolution. And then there's another revolution starting in January to January again. So the period, the length of this revolution is 12 months. So we're going to use that 12 months to find the b in the equation. So thinking back to earlier in this chapter, there was an equation that said the period equals 2 pi over b. Well, we now know the period. The length of this revolution is 12 months. So we are going to solve this equation for b. What do I do next to solve for b? Times b by both sides, yep. So I have 12b equals 2 pi. And what's the next step? Divide by 12. And then we want to reduce that fraction down to pi over 6. So this will go in our equation right there. The next thing I do is I find what we call the principal axes. It's how much does the graph shift up or down from the traditional parent function where the horizontal axis was at the x-axis y equals 0. And that'll help you to find the d in the equation. So if we go back to this graph, does our graph shift up or down? It shifts up, because traditionally our parent function would look like, this. But ours doesn't, so it's shifting up. We have to figure out how far up it goes. So what you can do is you can take the maximum on the y-axis and the minimum on the y-axis. And then what you're doing is you're finding the midpoint. So where is the maximum temperature in this set of data? Right here, 28. There's your maximum temperature. What is your minimum temperature? 15 in July. And you want to find the halfway point with that data. So it will be 6.5. So you're trying to find out what is the halfway point from here to here. So we're going to add those two up and then divide by 2 using the midpoint formula. So we said the maximum temperature is 28. The minimum temperature was 15. And then we divide by 2. So 28 plus 15 is 43. Divided by 2 is 21.5. So my graph shifts up 21.5 degrees.
Is it supposed to be plus or minus?
The next one is what you're talking about, is the minus, and that'll be your amplitude when you minus it. So now I can go back up to this graph and create the horizontal axes. So when I go up 21.5, there is my principal axes. Now what we want to do is find the amplitude next. How far up on the principal axis and how far down does my sine wave go? What is that height? So now we're going to subtract the maximum and minimum. The distance between the maximum and minimum, and then divide by 2. And that will help you to find the A in the equation. So the maximum again was 28. The minimum temperature was 15. And we divide by 2. 28 minus 15 is 13. Divided by 2 is 6.5. This will be your amplitude, or your A in your equation. To go back for a minute, this is going to be your D in your equation. I'm going to stop the recording there to finish up the problem.